Welcome back. Let's take a look at an example problem for a theory-based inference for paired data. So in this example, it's how many M&Ms would you like is the question. And more specifically, if I handed you a bowl of M&Ms, would the size of the bowl have an effect on how many M&Ms you grabbed out of the bowl? So more specifically, they had 17 participants, and they came in and they were offered either a small bowl or a large bowl, and they could take as many M&Ms as they wanted. And then at a later session, they switched the bowl size and they counted how many M&Ms they took. And so in this case, you can think about, okay, what are the observational units? Well, we have these 17 participants. The explanatory variable is categorical. It's whether the bowl was small or large. The response variable was quantitative. It's how many M&Ms they took out. And it was an experiment because they randomly determined whether they gave them the small bowl or the big bowl. And then the resulting data is paired because it was the same 17 people who took M&Ms with a small bowl and the big bowl. So we've got this natural pairing with the 17 participants. Okay, so if we take a look at the hypotheses for our setup, our null hypothesis is that the average of the differences is 0, or the long run mean difference in number of M&Ms taken is 0, and they did small minus large, so small bowl minus large bowl. And then the alternative is that the difference is not 0. The long run average of the differences in number of M&Ms taken, small minus large, is different from 0. So essentially we've got, we have all these individuals, how many M&Ms they took, and then we subtract those two numbers to get the difference in M&Ms. And the data is right here. So on average, for our 17 people took negative 10.88 M&Ms with a standard deviation of 36.3. So what would that mean? Small minus large, it's a negative number, so that means they're taking out more M&Ms with the large bowl than the small bowl. Okay, so they're taking out more M&Ms with the large bowl than with the small bowl. And we can see that it's not just, one M&M, it's, negative 10 here, so it's a good number. But will that be statistically significant? So let's take a look at the data. Here you can see, a couple really big differences. That's probably why our standard deviation is so big. And then some people took more, some people took less, right? But it looks like a lot more of these are over here, which is why our average is negative 10. Okay? And then what we can do then is we would want to know, well, what would be the null distribution of these differences, of these average of the differences, if we predicted it using a theory-based method. Okay? So if we're going to use a theory-based test, essentially we're just going to do a test for a one mean using the differences as our data. Okay? And so if we jump over to our applets, really we can just use our theory-based inference here, and we can set it up for one mean. Okay? Now if we had the data we could paste it in, but in this case we just have 17 people. I think negative 10.88 was the sample average of the differences, and the standard deviation was 36.3, so we can put 36.3 there. We can calculate a test of significance, and what this will show us is this is what the null distribution would look like if we predicted it using a theory-based test based on the kind of data we had in our sample, right? And it turns out that the observed difference was negative 10.88, and that line would be here at negative 10.88 and at 10.88 here because it's a two-sided test. And you can see that that's a very typical kind of thing that could happen even if the average of the differences was 0, and so you get this p-value of 0.234, right? So we have, in this case, evidence that there is a difference, but the evidence isn't strong enough to be statistically significant. Okay, so so that's sort of the conclusion we might make for a theory-based test. Now, you might wonder, are there validity conditions for a theory-based test? Well, you're supposed to have 20 observations, and we only had 17. And the data is not supposed to be strongly skewed. Now, our data, it doesn't look to be skewed one way or the other. There's sort of a symmetric kind of shape to it. But there's only 17 observations, so really the validity conditions wouldn't be met for a theory-based test in this case. So we probably should do a simulation-based test, but the fact that it wasn't significant, and it was not significant by quite a large margin here, so I don't think it's really going to make a big difference in this case. Our evidence just isn't strong enough because our sample size just isn't big enough. Okay, so the conclusions. We don't have strong evidence that bowl size affects the number of M&Ms taken. We had a difference observed, but it wasn't big enough. The p-value was bigger than 0.05, so we weren't able to reject the null hypothesis that the average of the differences was 0. And we could make a confidence interval. Okay, so let's see how the confidence interval gets made. And if you check the other button for confidence interval, 95% confidence interval, it will make one for you. And then we can interpret that. So we're 95% confident that when given a small bowl of M&Ms, a person will take between 29.5 fewer M&Ms to 7.8 more M&Ms on average than when given a large bowl. So that's that fact that confidence interval is negative 29.5 up to 7.8. It could be that people take fewer M&Ms with a small bowl. It could be that they take more M&Ms with the small bowl. It could be some number in between. It could be 0. It could be the same, right? We just don't have strong enough evidence to know, in a very tight range, whether people take more or fewer M&Ms with the small bowl or the large bowl. All right. And you might wonder, well, why wasn't our result significant? It could be that the bowl size doesn't matter. It could be that the bowl size does matter, but the difference was too small to detect with our small sample size. So we just didn't have enough power in our test to detect it. So we could have made a type 2 error here. It could be a missed opportunity, or it could be the null hypothesis is true. And maybe bowl size matters with some foods, but not others, or something else. All right. So that's kind of how you do a theory-based test. Essentially, it's the same as a test of one mean. You just look at the differences, and that's a thing of data, and you can do a one mean test on it. And the exploration that you should be doing next is comparing auction formats. So go ahead and get cracking on that. And if you have any questions, be happy to answer them. Just send me an email or get in touch one way or another.